Airport characteristics related to airport design. Welcome to our exploration of airport characteristics related to airport design. Designing an airport involves meticulous planning and consideration of various factors to ensure safety, efficiency, and functionality. Today, we'll look into the key components of airport design, including the sizes of various elements, turning radius, speed, runway characteristics, sight distances, runway intersections, taxiways, clearances, aprons numbering, holding aprons, and essential aerodrome data terminology. Let's start with the sizes of airport components, turning radius, and speed. The size of airport components is critical in airport design, as it affects the capacity and type of aircraft that can be accommodated. Key components include runways, taxiways, and aprons. Runways are designed with specific lengths and widths to support the largest aircraft expected to use the airport. Taxiways are sized to facilitate the movement of aircraft between runways and other facilities without causing congestion. Aprons are determined by the number of aircraft that need to be parked, loaded, unloaded, or refueled simultaneously. The turning radius of aircraft affects the design of taxiways and aprons. Larger aircraft require wider turns, impacting the layout of the airport. Designers must ensure that taxiways have enough clearance for aircraft to make turns without encroaching on adjacent areas. Speed also plays a crucial role. The speed of aircraft during various phases of operation, such as takeoff, landing, and taxiing, influences runway and taxiway design. Runways must be long enough to allow aircraft to reach takeoff speed and come to a safe stop during landing. Taxiways should accommodate safe taxi speeds without causing delays. Now, let's discuss runway characteristics, specifically runway length and width. Runway length and width are critical factors in airport design. They are determined by the types of aircraft the airport will serve and the climatic conditions of the area. Longer runways are needed for larger aircraft and in hotter climates, where air density is lower, reducing engine performance. Wider runways accommodate larger aircraft and provide extra safety margins during takeoff and landing operations. Sight distances are crucial for ensuring pilots can see and respond to potential hazards on the runway. Longitudinal sight distance refers to the visibility along the length of the runway, ensuring pilots can see any obstacles or other aircraft. Transverse sight distance pertains to visibility across the width of the runway, which is essential during takeoff and landing. Runway intersections must be designed to minimize the risk of collisions and ensure smooth traffic flow. Taxiways provide paths for aircraft to move between runways, aprons, and terminals, preventing bottlenecks and ensuring safe operations. Adequate clearances must be maintained between runways and taxiways, to prevent interference between aircraft operations. Next, we have aprons. Aprons are the areas where aircraft are parked for boarding, loading, refueling, and maintenance. The design of aprons must accommodate various types of aircraft and support efficient ground operations. The size of aprons is determined by the number of aircraft that need to be serviced simultaneously, and their layout is organized to minimize the distance between parked aircraft and terminal buildings, reducing turnaround time. Runway numbering is another critical aspect. Runways are numbered based on their magnetic heading, rounded to the nearest 10 degrees. This system helps pilots align with the runway during approach and departure. For example, a runway with a magnetic heading of 185 degrees would be numbered 19, while a heading of 005 degrees would be numbered 01. A holding apron, also known as a holding bay or run-up area, is a designated space where aircraft can wait before entering the runway. This area allows aircraft to complete pre-takeoff checks and engine run-ups, without obstructing other taxiing aircraft. Now, let's look into some essential aerodrome data terminology. The Aerodrome Reference Code is a standardized code used to classify airports, based on the characteristics of the aircraft they serve. The code consists of two elements: a numeric code indicating the runway length required by the aircraft, and an alphabetic code representing the wingspan and outer main gear wheel span of the aircraft. The Aerodrome Reference Point, ARP, is a designated geographic location that represents the center of the aerodrome. It is usually situated near the geometric center of all runways, and serves as a reference for charting and navigation purposes. The Aerodrome Reference Temperature is the average temperature used for designing airport facilities, particularly runways. It considers the highest temperature expected during the hottest month of the year, and is critical for determining runway length requirements. Higher temperatures decrease air density, affecting aircraft performance during takeoff. In summary, airport design involves a meticulous process that considers the size of various components, turning radius, speed, and other critical factors to ensure safety and efficiency. Runway length and width, sight distances, runway intersections, taxiways, clearances, aprons, numbering, and holding aprons are all essential elements that contribute to the overall functionality of an airport. Understanding basic aerodrome data terminology, such as the Aerodrome Reference Code, Aerodrome Reference Point, and Aerodrome Reference Temperature, is crucial for designing airports that can accommodate various aircraft types and meet operational demands. Effective airport design is a blend of engineering, safety considerations, and operational efficiency. By carefully planning and considering all these factors, we can create airports that not only meet current needs, but are also adaptable for future growth and technological advancements. Thank you for joining us on this journey through the complexities of airport design.